Dear student, Assalamu alaikum. Hope all of you doing well. This is Econometrics 1 and today's our lecture is Classical Econometric Modeling. I am your instructor Hafiz Muhammad Qasim. Classical Econometric Modeling. In the previous lecture, we discussed about the definition of the econometrics, literal meanings, scope of econometric and econometric methodology. The recap of the last lecture: the economic theory, mathematical model of theory, econometric model of theory, data, estimation of the econometric model, hypothesis testing, forecasting or prediction using the model for control or policy purposes. In this lecture, we discuss the classical econometric modeling. MPC. What is MPC? MPC is the marginal propensity to consume. That is the rate of change in consumption, say in $1 by change in income. Number 2, the specification of the mathematical model of the consumption theory. Single equation model. Here y is equal to alpha plus beta 1 x, where beta 1 less than or equal to 1 and greater than or equal to 0. Here y is equal to consumption expenditure and dependent variable. X is equal to income and independent variable or explanatory variable. Alpha is equal to intercept and beta is equal to slope coefficient. Beta 1 represent the MPC, marginal propensity to consume. In section 2, we convert our Keynesian theory into the mathematical model. Here is the diagram. X-axis represents the income and y-axis represents the consumption expenditure. Here is the line, straight line of our regression equation. Number 3, the specification of the econometric model of consumption. The relationship between economic variables are generally inexact. In addition to income, other variables affect consumption expenditure as well. For example, size of family, age of the members in the family, family origin, etc. are likely to exert some influence on consumption. To allow for inexact relationship between economic variables, in model 1, we modified as follows: y is equal to alpha 1 plus beta 1 x plus epsilon. Here we add, in the previous mathematical model, we add mu, that is the error term. What is the difference between the mathematical model and econometric model? The only difference between the mathematical model and econometric model: in econometric model we include the error term, that is mu in blue color, where error term mu, known as the disturbance or error term, is a random stochastic variable. The disturbance term mu may well represent all those factors that affect consumption but are not taken into the account explicitly. Number 2 is an example of the linear regression model, that is the hypothesis that y is linearly related to x, but that the relationship between two is not exact. It is subject to individual variation. The econometric model can be depicted as shown in figure 2 in the next slides. This is the figure 2, shows the econometric model. On x-axis we take the income and vertical axis we take the consumption expenditure, and straight line is the regression equation line where the dots shows the distance between the variable, shows the error term. Number 4, obtaining the data. To obtain the numerical value of alpha and beta, we need data. Look at the table 1 in the next slides, which relates to the personal consumption expenditure, PCE, and gross domestic product, GDP. The data are in the real term. Here is the table. The table 1, data on the X and Y variables from 1982 to 1996. Y and X data were taken from the World Development Indicator, that is the WDI. To estimate our model 2, we should obtain data either primary or secondary, time series or panel or pool data. We discuss the types of data in detail in the next lecture. The data are plotted in figure 3. Here is the data points, GDP and personal consumption expenditure. The straight line shows the positive relationship between income and consumption. Estimation of the econometric model. Our next task in classical econometric modeling to estimate the model or to obtain the values of alpha and beta. Regression analysis is the main tool used to obtain the estimates. Using this technique and the data given in table 1, we obtain the following estimates of alpha and beta, namely minus 184.08 and 0.7064. Thus, the estimated consumption function is y hat is equal to minus 184.08 plus 0.7064 xi. This is the equation 3. The estimated regression line is shown in figure 3 in the next slide. The regression line fits the data quite well. The slope coefficient, that is, here the slope coefficient beta is equal to 0.70, represent the MPC, that is the marginal propensity to consume, was about 0.7. The economic meaning of the 0.7 is that an increase in the real income of say $1 led on average to an increase of about 70 cents in the real consumption. Our next task is the hypothesis testing. That is to find out whether the estimates obtained in equation 3 are in according to the expectations of the theory that is being tested. Keynes expected that the MPC to be positive but less than 1 or greater than 0. In our example, we found that the MPC, that is the marginal propensity to consume, to be about 0.7, but therefore we accept this finding as confirmation of the Keynesian consumption theory. We must inquire whether this estimate is sufficiently below unity. In other words, is 0.7 statistically less than 1? If it is, it may support the Keynes theory. Number 7, forecasting or prediction. To illustrate, suppose we want to predict the mean consumption expenditure for 1997. The GDP value for 1997 was $7,269.8 billion. Consumption would be Y hat 1997 is equal to minus 184.0799779 plus 0.7064 into x. Here we put the value of x, that is the value of the GDP in 1997, $7,269.8 billion. And when we estimate, multiply or add or subtract this equation, we will get the 4,951.3 predicted value of y in, that is the predicted value of personal consumption expenditure if the GDP is the 7269.8 billion. Now suppose the government decide to propose a reduction in the income tax. What will be the effect of such policy on income and thereby on consumption expenditure and ultimately on employment? Obviously, tax cut increase the income, increase the consumption expenditure, and when consumption expenditure increases, there is a more production required, and for more production there is a more employment generated. Here is a positive impact on all the variables and trickle down effect actually. Suppose that as a result of proposed policy change, investment expenditure increases. What will be the effect on the economy? As macroeconomic theory shows, the change in the income following a dollar's worth of change in investment expenditure is given by the income multiplier M, which is defined as income multiplier M is equal to 1 over 1 minus MPC. The multiplier is about, when we put the value 0.7, we will get 3.33. That is, an increase or decrease of the dollar in investment will eventually lead to more than a threefold increase or decrease in income. Note that it takes time for the multiplier to work. The critical value in this consumption is MPC. Thus, the quantitative estimate of MPC provides the valuable information for policy process. Knowing MPC, one can predict the future course of income, consumption, expenditure, and employment following change in the government fiscal policies. Number 8. Use of model for control or policy purposes. Suppose we have estimated consumption function given in equation 3. Suppose further the government believes that consumer expenditure of about 4,900 will keep the unemployment rate at its current level of about 4.2%. What level of income will be guarantee the target amount of the consumption expenditure? If the regression results given in 3 seem reasonable, simple arithmetic will show that 49,000, that is the value of consumption expenditure, personal consumption expenditure, minus 184.0779 plus 0.7064x, which gives x is equal to 719. We manipulate this equation, that is, add 184 in 49,000 and divide 0.7064 to get the value of x. By manipulating equation 6, we will get value of x, $7,197 billion, given an MPC of about 0.7, will produce an expenditure of about $4,900 billion. As these calculations suggest, an estimated model may be used for control or policy purposes. By appropriate fiscal and monetary mix, the government can manipulate the control variable x to produce the desired level of target variable y. Dear student, in the next lecture, we will study about the data and the different types of data, measurement scales, role of computer applications in econometric, different sources of data. Thank you.